Okay, so I'm going to go over the start of all our transformations. In essence, what this is the transformation of various functions by the same values that were used to last day, okay, or last year, I should say. So we're going to deal with vertical transformation factor, horizontal translation factor, or horizontal translation component, and then a vertical translation component. So what we're going to do is we're going to go ahead and go through this investigation. And as we go through this investigation, okay, we'll be able to see things. I'll also be able to show you, not on Geometry or Sketchpad, but I'm going to use Desmos in order to show you that. So let's look at these functions first, and we'll get used to the table of values and what happens to them. So number one says, on the base function y equals root x, okay? So I want to graph the base function, all right? So the base function, if you remember, for y is equal to root x. 4, 1, 0, 2, 1, 0. Okay, it was this basic function with a point here, and a point here. And it just sort of took off like that. Okay? Now, the next function that I want to graph is this guy. Okay, y is equal to x minus 4. Okay? Now, if I graph y is equal to x minus 4, what I actually end up with is a difficult situation, because if I put in 4 and I go 4 minus 4, I'm going to get 0, which is wonderful. But if I put in 1 and I get 1 minus 4, I'm going to get a negative 3. So I have to use a different sort of set of table of values. In actual fact, what I should be using is the number 8, okay, the number 5, and the number 4, okay? So 4 minus 4 gives me 0. 5 minus 4 gives me 1. Square root of 1 is 1. And then 8 minus 4 gives me 4. Square root of 4 is 2. Now, what we're really designed to do is we really should be graphing these on Geometry Sketchpad was the original design here, but really what it is Desmos, okay? So if I want to graph the square root of x minus 4, what does it look like, okay, before I do my table of values? So if I go to Desmos, and this is Desmos, you can just go to Google Desmos and go to Desmos Graphing Calculator, and you can do the same investigation yourself. So the first thing I'm going to do is I'm going to go y. There's a little keyboard down here that you can press and it opens it up for you. Okay, or you can type it in from your keyboard if you want, but if you're on your phone, you need to use this, or on an iPad or something like that. Okay, so y equals, and then we want to do the square root of x. Okay, and it immediately draws it for me. Okay, and it's got that 0, 0, it's got 1, 1, and it's got 4, 2, those key points. Now what I'm going to do is I'm going to draw the next one. So I go to the next function. I don't know if it's going to do the same color or a different one. We may have to adjust the colors. 1 second. Okay. Then I go y equals, and if you look back at our handout, it's the square root of x minus 4, but the x minus 4 is underneath the bracket. Okay, underneath the bracket. Okay. So then I go square root, and I'm going to bracket it to make sure that's underneath that square root sign, and then I'm going to go x minus 4. Close my bracket. Okay, and it's going to draw it for me. And it draws it in blue. And so this is y is equal to x minus 4. And what you've seen is, with the minus 4 inside the square root sign, it shifts it to the right forward. If you remember from last year, you're like, hey, it's a plus or minus one. I remember the plus or minuses did shifts left and right. Okay, so if I'm going to do shifts left and right, okay, then what sort of is going on there, or what does the 4 do? Well, first of all, if you'll notice, it goes 1, 2, 3, 4 units to the right. Or if we change this, I don't know if I can change this scale. I don't want to do it on the computer. I don't know how to do it when it's in. No, the scale's going to stay as it is. Yeah, so there's 1 square is 1, okay? And so you're going to see that it goes 1, 2, 3, 4 units, where each square is 1 unit. Okay? And so you'll notice that this point goes to the right 1, this point goes to the, sorry, this point goes to the right 4, this point goes to the right 4, and this point goes to the right 1, 2, 3, 4. A little bit more difficult for you to see. So what does x minus 4 inside the brackets do? It shifts to the right 4. It didn't change the shape of the parabola, or half parabola, the root function. What it did was it just moved every single point to the right 4. Now, it's a minus 4, so you think minus will go in this direction. But remember, it shifted to the right. And if you remember from last year, okay, and we looked at our base function for quadratic, when we had this situation here, okay, where when we had y is equal to a x minus h squared plus k, and what we were originally graphing was the function y equals x squared, then what you'll notice is that inside the square root, or inside the squaring, is my left or right thing. If you remember, for this one we had to change the sign when we were figuring out the h value, or the horizontal translation factor. And that's what it is. It gives you shifts. It shifts things to the right 4 units. So if I'm going to draw it here, and I'll draw it using this color, and then I drew y equals x squared using this color, okay, then it's going to have a dot here. That's going to move 4. That's going to move 4. 1, 2, 3, 4 spaces. And that's going to 1, 2, 3, 4 spaces. Okay? And so I connect the dots there, and that's going to be y is equal to root x minus 4. Maybe I'll move that. I'll get rid of that. And I'll put it down here. Y is equal to the square root of x minus 4. Okay? And this is going to be y is equal to the square root of x. All right? So, if we're inside the root, like when we're inside the squaring, remember the function is a root function. So if you're inside plussing or minusing, and you're inside plussing or minusing, you shift from left to right. Okay, so if this said x minus 4, we would be shifting our parabola to the right 4. Because inside it's x minus 4, we shift the root function to the right 4. Okay? And we can make a comment, okay? Same shape. Oops, sorry, I should do it in blue because that's what I wrote the function in. Okay, so it's the same shape. All points shift that way 4 units. Okay? And that's what we see. Now the next one we want to do is a root y equals root x minus 3, but the minus 3 is on the outside. So see if you can think about what that is. Okay, see if you can think about what that effect would be based on what you remember from last year. I'm going to do this guy in green. Let's go all the way over to Desmos. Okay? And I've got these two functions already in here, so this is the graph that we just sketched over here in red and blue. And the next one that we're going to do, okay, I don't know if I can change that color. I think I've got to go over here and change the color. And I can't see it on the smart board. Anyway, I go y equals square root of x, and then outside of it, so I got to get it outside of it, I go minus 3, or was it plus 3? I'm trying to remember what it is. Anyway, it's green, which is what I want. Let me just check to see if it's the right one. Minus 3, good. Minus 3. Okay? And as a result, what does that do to the function? Well, as soon as we finish writing it, it immediately posts it for us. And what you'll see is, compared to y equals x squared, from the red, y equals x squared, comparing it to the green. So comparing the top to the bottom, what we see is 1, 2, 3, down 3, down 3. If you see this point, 1, 2, 3, down 3. Okay, if you see this point right here at 4, 2, that goes 1, 2, 3. There it is, down 3. So in essence, what happens is, okay, that if we have a situation, let me scroll down a little bit. If we have a situation where we have our red root function, okay, and we compare it to doing a minus 3 and it's outside of the bracket, okay? So if we're going to go here, it would be outside of the bracket. So this is where the -3 would be, outside of the squaring. Outside of the squaring is where we found our k from last year. Now we're not going to use the letter k anymore, but that's the idea. Okay? So this number that's outside of the function, added or subtracted to it, does exactly what's expected. We don't have to switch the sign. We just go down 3. And so as a result, what do we get? We go down 1, 2, 3, down 1, 2, 3, and then up here, let's scroll a little bit. And then we go down 1, 2, 3. And then we draw the function. And that's y is equal to root x minus 3. So now we've seen two different players. The player that's inside the root, or inside the function, moves left and right, the opposite of whatever the number is. -4 doesn't move -4, it moves +4. And then if it's outside of the function, outside of the root, it moves it, in this case, down 3. And the reason why it moves it down 3 again is because that 3, I'm wondering if you guys can even see that. If it's correcting for brightness. It's difficult for me to see. I'm going to get rid of some of the brightness here. And so it's moving it down 3. Okay? So what's the expectation? Same idea. It's the same shape. Oops. As y equals root x, I should probably say. Y equals root x. Okay? But it's shifted down 3 units. Okay? Not crazy, but it is what it is. Now we have this scenario where we have this sort of super hybrid function. Okay? And we want to compare it to the parent function, y equals root x. So we go ahead and we take this function, if you can see it here, y is equal to square root of x minus 4 minus 3. Okay? And I'm going to go to Desmos, and I'm going to add a new one. Okay? I'm going to go y is equal to, I'm going to do my square root sign, and I'm going to do the part that's underneath the square root sign, which is the x minus 4, and then I'm going to go outside of the root sign. I need to do this in my computer, I think. Not quite sure how to cursor over. And then I'm going to go minus 3. Okay? So I don't know if you can see it over here. It's probably kind of small. But I've put in y is equal to root x minus 4 and then minus 3. Now it's already drawn it for me. Okay, I'm going to change it from purple because I don't have purple on my smartboard. I'm going to change that to shift. Well, we're just going to have to go with purple, and I'll use black. Okay? So what you'll notice is two things have happened. Again, I'm comparing the red to the purple. Okay, red to the purple. Okay, can you see that? Yeah, I guess you can see that. The red to the purple. Okay? What's happened here is that not only has this point gone, I'll use the black marker. Not only has this point gone down 3, but it's also gone 1, 2, 3, 4 to the right. And if you'll see, we've got a minus 4 and a minus 3. So it's kind of a combo of the green and the blue function. That's the purple function. This one goes over 4, and the purple one is over 4. This one goes down 3, and the purple one goes down 3, but it just so happens that the purple goes over 4 and down 3. Okay? And that's going to be both my h and my k values, or the values that we're going to use. We're going to use different letters called c and d. So what happens to this function? Well, if I graph what I see, I'm going to go back up to the original equation here, then I'm going to go ahead and I'm going to say, okay, for this one I go over 4 and down 3 for this point. And then I go, from this one I go over 4 and I go down 1, 2, 3, oops, sorry. Over 4, 1, 2, 3, 4, down 1, 2, 3. Unfortunately, I'm right in the midst of my writing that I did there. I didn't foresee that. And then again, from this point, I go over 4 and I go down 1, 2, 3. and I'm left with this sort of a scenario here. Okay, and that's going to be y is equal to the square root of x minus 4 minus 3 on the outside. Okay? And that's really what's happening. Those are my two translation factors. And those happen exactly the same way. If I asked you to do this way back in grade 9, you would take the parabola and you would take probably its vertex, right? And you would shift it to the right 4 and down 3, and then you draw your parabola. Again, same shape. Same shape, moved 4 units, and moved down 3 units. Okay, and that's all that's happened to that in that situation. So for a function y equals f at x, what can you conclude about y is equal to f at x plus c? So if I take something like y is equal to the root of x, and I go to y is equal to the root of x plus c, and we call it c, we don't call it k anymore. That's the same thing as y is equal to any function, not just a square root, is y is going to be equal to any function, okay, plus c, means that it's going to shift up or down c units. Whatever the units are. Look, I'll put c in like little c units. Okay, whatever it is. Okay, because that's what the guy outside does. See how this is out, this is the function outside of the function. Okay, again, the 3, negative 3 is outside of the root. The negative 3 is outside of the root. That's when it moves down. For a function y equals f at x, like y is equal to the root of x, if we go y is equal to the root of x minus d, and we use the letter d, and that's the one that's inside. See what's inside the square root? It's like in the square root itself. Or, if this is my generic function, which means it works this way for any function, whether it's a parabola or a root function or whatever, y is equal to the square, sorry, not the square root, f at x minus d. So you notice that it's inside the bracket. It's in the function. Okay, and it's added or subtracted. Okay, in this case, it shifts left or right d units. The key here is this is going to be a vertical, and this is going to be a horizontal change. Okay? And that's the key for what's happening there. Okay, that's the key for what's happening there in the graph. Okay, and in any graph for that matter. Because when we do it for a root and we do it for any function, it's still going to do the same thing. Okay? All right, next page. All right, so graph the absolute value function. Okay, so there's my absolute value function. If you remember your absolute value function, it's a pretty simple, straightforward one. I'm going to make this red. Okay, I draw one there, like that. And then I draw one like that, one like that, one like that. Well, I'm not going to do too many points. That's more than enough. And there's your absolute value function. It's like a pointy parabola, okay? But it's like a line that goes this way and then stops and then turns in the opposite direction and goes that way. Now, what I've done here is I want to graph y is equal to 2 times the absolute value of x. So I think blue is my number for that one. So I'm going to do this one in blue. Now, I'm going to go to Desmos and let Desmos do the work for me. Now, I have to delete all these guys. I don't want to have too much junk on this function over here. And I do want to sort of see, fairly closely what's happening here, near to what I'm writing. Okay? So I'm going to go ahead and put it in here. I'm going to go, I don't know what color that one is. I want to make it red. We'll see how it goes. Y equals the absolute value. Your absolute value is right here. And then x. Okay, and there it is there. So it started with black. Okay, so I'm going to have to start with black for my absolute value function. Okay, for the next one, y is equal to, and you'll notice that the 2 is on the outside of the function. Okay, there's a 2, and then you have the absolute value. Okay? So if you go ahead and you look at the 2, you'll see that the absolute value function is this little straight brackety thingy. The 2 is outside of the straight brackety thing. Outside of it. Multiplied, scooched right next to it. It's multiplied. It's not added or subtracted. It's multiplied, but it's outside of it. Okay? And then the result, of course, of graphing those two is we get this. Okay? Now, who is who? The black line is the absolute value function. The red line is y is equal to 2 times the absolute value function. So I'm just going to go ahead and I'm going to redo that. And of course, I'll label it on a nice, beautiful grid that we have here. So I'm going to redo the basic absolute value function, my parent function, with 0, 0, 1, 1, 2, 2, and then 1, 1, negative 1, 1, and negative 2, 2. And I draw that absolute value function. Okay, there it is there. Now, the y is equal to 2, so that's y is equal to, that's black. Oh, pardon me. So that's black. That's red. Okay, so what I see here is you'll notice that this point here stays the same. Okay, when you go back to your, that point's the same, the red and the black. It's the same point. Okay, but then you'll notice that for the black line, I go over 1 and up 1. See, I'm at 1, 1. But here it's at 1, 2. So this point is twice as high. Okay? Twice meaning 2 times as high. So this is normally 1 space, now it's 2 spaces. Now, we're going to really look at the 2. It should be 2, 2. But now we're going to look at over at 2. It should be 2, 2, but instead over at 2, it goes up to 4. Which means it hasn't just increased it by 1. What it's done is it's doubled it. Okay? It's doubled its height. Okay? So I go over to 2. Instead of 2, 2, I take this distance of 2 squares and I double it to a distance of 4 squares. And so that's sort of the right-hand side of this absolute value function. What I do, I should do to every point equally. So if I doubled the height of this guy, I should double the height of this guy. Okay? If I double the height of this guy, that's 2 units, and I double it to 4, then this 2 units should get doubled to 4 as well. And so I end up coming up with a function that looks like this, or it's sort of twice as high. Okay? So again, that's y is equal to 2 times the root of x. And this is y is equal to just the basic root x, base function or parent function. Okay? So compare this to the function. Okay, well, how do I compare it? It's in the same location. Okay, at least for the vertex. Vertex thingy. So no shift has happened, but it's a vertical stretch. And it's times 2, or by a factor of 2. That's no magic, no random number. It's exactly what you should expect. Now this next one's got a couple of things going on with it. So the next one that we're going to graph on Desmos, okay, is the same thing. We're going to have the, so if you remember, we've got the function. It's got a negative 3 on the outside of it, but it's scooched right next to it, so it's multiplied. So this is my negative 3 is multiplying by this function, okay? It's multiplying by this function. Now I don't know what color it's going to be, okay, but it's a negative and a 3, okay? Now hopefully you can make a guess about what the negative is going to do. But then we've also got a 3. A 2 doubled the height. So the guess is the 3 will triple the height. What will the negative do? Do you remember from last year? So let's go ahead and let's see what happens when we go ahead and we put this in. I don't know what the color is going to be, and I've forgotten how to adjust the color. I know how to do it at home, but I can't do it here. Either way. So y equals negative 3. Okay, there's my negative 3. And then I do my absolute value function, and I put in x, and that's it. And what you'll see, it's a little bit difficult to see because there's so little of it. What you'll see, though, is we have this blue function. Now, the normal black function is, okay, it's normally 1, 1. Now, our hypothesis probably was that the 3 is going to triple the height. that means it would be up here. So 1 square becomes 3 squares, and 2 squares becomes 6 squares. Well, it's not up here, it's down here. But remember, we had a negative 3. So what we actually do is we take this value here of 1, and we don't just triple it for the 3, we times it by negative 3. Okay? So see how this is 1 square above? If I multiply it by negative 3, if I take this 1 and I multiply it by negative 3, instead of it being 1, it becomes negative 3 right down here. And if I take this value here, which is 2, my y value, and I multiply it by negative 3, it becomes negative 6 all the way down here. And the same thing on the other side. This is 1. I could times it by 1 times negative 3 is negative 3. And then if I take the next one, it should be 2. Okay, I times that by negative 3 and it becomes negative 6. Okay, so what has happened because of that negative 3? And again, it's done in blue, so we're going to use blue. Okay, this point here still stays the same. Because it's 0 away, when you take 0 and you multiply it by negative 3, it stays the same. When you take this 1 and you multiply it by negative 3, it triples in size, but it goes to the other side. Okay, so it reflects with the negative, and it stretches with the 3. This one, same idea. Instead of tripling, it triples, and it goes to the other side. Finally, this one here, that's a 2, it triples, okay, to 6, but then it goes to the other side. Or I guess you could do it in an alternative order, and you could say it goes to the other side and then it triples. Whatever you want, but it does both of them.